welcome. I'm very pleased today to have us. Sorry about that. I'm very pleased today you are with us for the session dedicated to the durian fruit, and I will be with Professor Tan today from the University of Putra, Malasia. Hello, Professor Tan.
Yes, hello.
How are you today?
Yeah, I'm fine. Yeah.
Thank you. Thank you very
yeah.
much for participating.
Yeah, it's my pleasure to be here.
Thank you. And there will be another person for this session, my colleague from the application department, Berta Polanco. Berta worked for Hiperbaric. She's a HPP specialist, and she has performed with the team at Hiperbaric pilot plant some studies on validation, microbial validation on durian products. So she will present those results.
Right.
So I will start with my presentation. My presentation will be quite short. This is a presentation on the opportunity and benefit of HPP for durian manufacturers. I hope you see well my screen. So we dedicated this session to the durian fruits because this is really a fruit that is very much appreciated in Asia. It has health benefits. It boosts immunity because it has a high vitamin C content. It supports digestion due to its content in fiber. It strengthens the bones because it has a lot of mineral and reduce blood pressure due to high content in potassium. The market is big. The main producers are in Thailand, in Malasia, in Indonesia, and the main importers, the main consumers countries are China, Taiwan, and Singapore. Just to give you an idea of the global market, it's in 2024, it's around almost 10 billion US dollar. And it has a growth of, it's forecasted to have an annual growth of about almost 10%. And so it will be, the size of the market will be over 15 billion USD in 2029. So this is really a large market, and the opportunity for the manufacturer is to grow this market, to export, of course, a fruit in good condition and with all the safety guarantee. The thing is, this fruit is highly susceptible to microbiological contamination because it has a pH over 5. And the water activity, I would say, quite low. So something like 0.87 or something like that. So the high pH of this fruit, not acidic at all, make the growth of the contaminant and some pathogen possible. So the high pressure processing can ensure food safety. How to implement HPP? From the plantation, the fruit is harvested, the flesh is removed, and it's vacuum packed and freeze. And so it can be processed whenever it's needed. So the unprocessed fruit can be exported to the consumer countries or to be processed in another location, or where is the HPP machine. Then when it arrives to the HPP plants, it's thawed, processed under pressure, and it can be freeze again and thawed after exported to the final consumer, or and so the shelf life could be very long, in very good sanitary and microbial quality. Hiperbaric has installed 7 HPP machines for processing durian fruit. 3 of them are exclusively processing durian. So in durian manufacturing in Malasia, Hiperbaric 55, Home's favorite in Singapore, and we have a confidential customer in China with a 135-liter machine. And we have 4 other machines giving the service, so we call the tollers, for processing for some customer durian pulp, durian products, the soup spoon, Commonwealth Logistic, and in Malasia, University of Putra, Malasia, where Professor Tan works, offer also this service in their pilot plants. So that's quite interesting technology, and it's expanding year after year. I take the opportunity to have Professor Xingping Tan with us to explain that University of Putra, Malasia belongs to a Hiperbaric HPP Academia network. And what is this network? Is a network of university, R&D, and lab testing center that has HPP machine and pilot plant. And they give educational classes, workshop to divulgate the technology, but also they have abilities to test the product, to help the food manufacturer to develop their products, and to do microbiological testing, to plan businesses, to explain how to use the technology, and also to give a recommendation to comply with the local or with the regulation of the country. Some few example of our North American partner of the HPP Academia network. You can see Cornell University, Florida International University, Nebraska. Well, we have several other university and technical center in Canada. In Europe, we have many partners, and our company Hiperbaric is based in Spain. So for a long time we sell machine to University and Technical Center in Europe, and our first Asian partner is the University of Putra, Malasia. So I'm very pleased today to have Professor Tan with us, and he has experience in HPP, University Putra, Malasia, and in this session he will share with us some results. So this is really a nice opportunity to discuss about the scientifically with Professor Tan about the durian fruit and process under pressure. So I thank you for your attention, and I'm very pleased to introduce Professor Tan. Is really one of the Malaysian exceptional researchers. So this is really an honor for us to have you with us. So just a small insight of his brilliant career. He's food technology leader at University of Putra, Malasia. So with a specialty in food emulsion, in extraction, in nanostructures, and of course, more recently, since 2022, experience in HPP. Professor Tan has published more than 500 scientific papers, 15 book chapters. He has 20 patents, and really is a leader in his country. And this is really an honor to have you with us today for explaining a bit about your research in the field of durian, very important in Malasia. Thank you so much.
Very much. Thank you, Carole, for the brief introductions and also very informative presentations on durian and the opportunity opened up for HPP and also company in Southeast Asia, especially we are kind of value this price tropical fruits a lot. So HPP provide an option for us to go about it. So let me share my presentations. Yep, slide. So Carole, can you see my slide?
Yes, perfectly. So the floor is yours, Sultan.
All right.
Thank you.
Okay, so greetings or hello from Malaysia. So I'm from Faculty of Food Science and Technology, the oldest food science and technology program in Malaysia. And I would like to share with you the impact of HPP on quality and also safety aspect for durian paste and pulp, which is two of the major products coming out from these prize tropical fruits. Okay. So can I proceed? So if
sure.
One, okay. So I'm in the content slide. So I hope that all of you can see my slides now. So I will provide a brief introduction to durian before going into the HPP processing on the design of the experiments. And subsequently, I will share with you the major findings and provide you a summary about the use of HPP in durian products. And I will also share with you another 2 months from now, we have a third International Food Research Conference and the HPP facilities in UPM. So if you take a look at durian, just like what you have shared by Dr. Carole, it is a tropical fruit and also a seasonal fruits. So usually we have about 2 seasons per year, a big seasons and a small seasons. So commonly also known as king of fruits because of its unique flavor and texture. So grown in Southeast Asia regions, especially Malaysia, Thailand, part of Philippines, and also Vietnam, plus Indonesia. So it has a very unique feature, a sharp hexagonal tones. If you take a look at this picture, you will know that it has thick and also sharp hexagonal reed. Plus with, if you open up, you will have about 1 to 5 durian pulps per side and yellow golden color, usually creamy and also white durian pulp. Durian is of high demand mainly due to its unique fragrance, aroma, and also texture. And due to increasing concern about use of preservative and consumer demand towards healthy, fresh-like fruits, therefore, farmer, manufacturers, and also government authorities are working very hard to come out or to produce high-quality and safe fruits for both local and international markets. So in this particular work, I will share with you both durian paste and also pulp. So pulp is just flesh of durian, but paste usually without seeds, and it is usually used together with other type of food for various food applications. So common commercial processing practice usually using thermal, or some company are using irradiation as well besides use of preservative, but thermal treatments are not good for, especially for durian as a fruit, because due to significant change in texture, color especially, and also aroma or sensorial properties. So HPP provide an opportunity or such as an emerging technology for durian processing. So I'm sure that this HPP Innovative Week, everyone is well versed about the benefit of HPP. So you have basically a non-thermal processing with minimum or no heat exposure. So this in return give you preserved colors, nutrients, and also flavor, especially for fruits. And not to mention also it has rapid and uniform hydrostatic pressure treatment and no reported toxicity results. And it will help us. One of the main reasons is to inhibit microbial growth plus with inactivations of some unwanted enzyme. So in this particular research work, we evaluate both the durations and also the pressures applied. So both to durian pulps and paste. So for pressures, we are using 300 up to 600 megapascal, holding times of 3, 5, 10, and 15 minutes. For physicochemical analysis or microbial analysis, we test the proximate compositions of both durian paste and durian pulp before and after the treatment. That also include color. While for microbiological properties, we test TPC, yeast and mold count, total presumptive coliform, and also E. coli, plus with the psychrophilic bacterial count. And we also evaluate the effect of the HPP on polygalacturonics enzyme activity. So a quick sharing of the results. So for proximate analysis, that is durian paste and durian pulp, it is quite clear that they are high moisture food products, having almost more than half of moisture content. It also have quite high in terms of carbohydrate plus high fiber. So while protein and fat make up of about less than 10% of the overall content. So some major findings from our proximal analysis show that they have comparable proximal compositions between durian paste and durian pulp. HPP retained the original nutritional values of both durian pulps and durian paste. Applications of HPP, whether it is at different pressures and different times, have no significant impact on the proximate compositions. Overall, the quality of durian pulp and durian paste are very good, and they are not affected by the study pressures or times. Next, take a look at color. So during heat treatments of durian, all of us are aware that durian will get significantly darkened in color, and that will degrade or reduce the value of durian. But good thing about HPP, there is no significant changes in terms of hue and chroma values, both for durian paste and durian pulp. But for brightness, there is no changes in terms of brightness for durian paste, but for durian pulp, we observe slight change when we use pressure above 400 or 600 megapascal. There is a slight impact on the brightness. So the most important things about safety, we take a look at microbiological quality. So while at lower pressure, HPP may not be suitable to reduce substantially the amount of microbe, such as TPC and mold and yeast. But if we increase it to above 400 megapascal, we start to see significantly reductions in terms of the microbial count. So that goes to both TPC and also mold and yeast count, not to mention the total presumptive coliform and E. coli. So we don't see it after the treatments. So major findings from microbiological quality, the effective HPP in reducing microbial activity is quite encouraging, and in general there was effective reductions in total plate count, more and yeast count upon HPP treatment. So we see total plate count were below detection level at 500 megapascal for 10 minutes for paste and above 400 megapascal for 15 minutes for durian pulp. So more in yeast, almost the same, but for durian pulp you can even go below 300 megapascal for 10 minutes, sufficient to make more in yeast below the detection limit. So overall, HPP provides an option to lower the bacterial count compared to untreated samples. So we also test the impact of HPP on polygalacturonase activity, which have impact on the textures of durian. So polygalacturonase tend to degrade the pectin in return it make the fruits kind of soften during storage. So we would like to see the impact of this enzyme. So good things to say is that compared to control, we see the activity of polygalacturonase significantly reduced upon the HPP treatment. So this is for durian paste, while this is for durian pulp. For durian pulp, the degradation is even more because that durian pulp is together with the seed. So the enzyme activity really significantly reduced, especially when you subject the durian to up to 600 megapascal. So overall, reductions in polygalacturonase activity. Although treatment time may not have significant impact on the PG activity for both durian paste and durian pulp, but pressure play a more important role. So we see significantly reductions in PG activity for both durian paste and pulp. So pressure play a more active role in reductions of this enzyme activity. In summary, I would like to say HPP is an alternative method for fruit processing, not only suitable for durian. We also carry out a series of HPP treatment for all other tropical fruits. We see good results as well. Comparable physicochemical properties in HPP treated fruits with control, which is without the HPP treatment. HPP plays an important role in reducing both microbial and also enzymatic activity in durian sample, and it provides the possibility for manufacturers, for farmer or producers of durian to extend the shelf life and also maintain the quality, especially the proximate content and also aroma of durian paste and pulp. So generally, HPP provides solutions to the unpredictable seasonal supply of durian fruits. I would like to take this opportunity to also share with all of you coming month, August 6th to 8 August, we will organize a third International Food Research Conference 2024 with the theme Sustainable Food Industry Through Science, Technology and Innovations. And these are some of the keynote address and also sessions that we have. And at the same time, on the 6th of August, we would like to also highlight 3 workshops, half-day workshops, where we would talk very specifically on HPP for workshop number 2, which Dr. Carole will be with us. So we will have one specific workshop on HPP processing and also high-pressure thermal processing, sustainable and safe food preservation techniques. So I hope that participants of this HPP Innovation Week will have opportunity to join us in the first workshop for HPP in Southeast Asia, or especially in Malaysia. So these are some of the info. I would like to also take this opportunity to briefly introduce only 2 more slides to go. Pilot plant. We have a new pilot plant in University Putra, Malaysia, that house the Hiperbaric 55 unit. So we open up for either research or to processing as well, as mentioned by Dr. Carole. So far we have treated mainly on durian product, also on coconut water, juices, and also meat-based or some other protein-based product as well. So I hope that we will have the opportunity to see some of you using our facilities in University Putra, Malaysia. Thank you.
Thank you very much, Professor Tan, for this a very interesting presentation and on durian. And also, I strongly encourage our audience to go to Kuala Lumpur in August to be a participant, to participate, to assist to the International Food Research Conference University of Putra, Malasia organized, and be with us also at the workshop. I think if you want to know more and to see the pilot plants, and that's really a good opportunity.
Thank you.
Thank you very much. I will now open the floor to my colleague Berta Polanco. So Berta will give the third part of the session. So Berta works as HPP specialist in Hiperbaric, and she has dedicated quite a lot of time and effort in the last weeks, month, I would say, to build with her colleagues a study, a validation study based on the microbial inactivation on pathogens, and we are lucky. The results we got are very similar to the one of the Professor Tan concerning the conditions, but it's an opportunity for us for the application department to dive more in the capability of inactivating pathogens, and hopefully in the coming month or next year, perhaps the results will be published. Berta, what do you think?
Yes, we will try to publish our results soon. So
okay,
yeah.
Because this is one of the role of the application department to reply to the question of our customer, and to learn more about the capability of our beautiful technology of HPP on great product like Durian, for example. And then we try to divulgate, to communicate, and to publish the results. So the first part of the results, or part of the results, Berta will show us now. So thank you, Berta, for the validation study of the durian you've done with the colleagues.
Thank you, Carole. So I will start with my presentation of HPP durian fruit pathogens and spoilage control. Can you see my screen now?
Yes,
Carole?
we do. Yes, we do.
Okay, so I'll start. So
yes.
As Carole already said, durian fruit is highly susceptible for microbiological contamination. So there's some foodborne outbreaks related with durian products, such as pastries or candies. So in these cases, some of the pathogens were Staphylococcus aureus. So as there's a food safety issue related with this product, we wanted to check the food safety related with the HPP processing of this fruit and their products. So at Hiperbaric, we conduct this validation about durian fruit. So for this research, we do two principal steps. A first one was a screening of the HPP conditions for durian. As already said, Carole, it has a pH around 5 and a very high water activity. So we have to apply a very extremely conditions for HPP. So the first step was to try 5 different conditions based in Staphylococcus aureus inactivation. And later we check the quality and spoilage indicators, the Tonello, lactic acid bacteria, Gisam molds, and Enterobacteria. And later we check the food safety of these conditions for the main 4 pathogens related: E. coli, Listeria, Staphylococcus aureus, and Salmonella. So for the first step of this validation, we do a screening of 5 different HPP conditions. We take a frozen commercial sample and we thaw it because it's distributed in frozen conditions. So we inoculate with Staphylococcus aureus because it's the most baclotolerance pathogen. So we inoculate with a high level of 7 logarithms, and later we apply the 5 different treatments. 3 single cycles of 6, 9, and 10 minutes, and a back-to-back cycle of 3 minutes, and a triple one of 2 minutes. So as a result, we achieve a reduction between 3 and 4 logs. That is very good. But we select the 10 minutes single cycle because of the higher inactivation and also to have the best productivity of the machines, as in a triple cycle, the machine suffers a lot. So it is better to have a single cycle one. For these conditions, we passed to the next steps, that was the quality and spoilage indicators. And we can see in this graphic that as the control and treated sample has a very good quality, the HPP was able even to inactivate less than 3 logs of these spoilage indicators. So this is an example that high pressure processing can improve the quality indicators of the durian fruit. And with the same condition, we try to mimic the boil process of the durian. So we thaw the same commercial samples and we inoculate with 4 different pathogens: Staphylococcus aureus, Listeria monocytogenes, Salmonella, and E. coli, with the high level inoculation of 7 logs. And later we apply the same HPP conditions, the 10 minutes single cycle, and we count after the treatment. And later we also freeze the samples and thaw and recount to see if there was an effect of freeze these samples. So for this last step, we check that we were able to achieve between 4 and 5 logs reduction after the HPP, and also that the freezing step was not really able to control the pathogens. There was only a slightly decrease of the Listeria and Staphylococcus aureus counts. So in this little validation, we wanted to sum up these results, saying that the high pressure processing provides an opportunity to gain a market share. Also, that the quality and spoilage indicators can be improved by this treatment. And it is a good result to know that it ensures safety for at least these 4 foodborne pathogens that we have already tested in our headquarters. So thank you so much for your attention.
Thank you very much, Berta. Thank you for this presentation. So it is now time to end this session. So I think I will wrap up the three main ideas we have explained in this session. So HPP doesn't change the flavor and the texture and the natural quality of the durian products. And but it allows to inactivate from I would say 3 to 5 log of the pathogens that can really compromise the safety of the product. So that's the two first idea of a technical or scientific idea of the session. And I would also conclude the session telling you that the third thing we have explained is that you should participate to the International Food Research Conference, ERFC, that the University of Putra, Malasia organized from the 6th to the 8th of August, if I don't make a mistake on the dates in Kuala Lumpur. So Professor Tan and myself and Kite Nozer, specialist of HPP, will be there. So very happy to see you in the real life in Malaysia. So thank you, Professor Tan. Thank you very much, and thank you, Berta, for your presentation. And with this, I send you my greetings. Bye-bye.